Hello everyone. In this video, again we'll consider one more example of finding the inverse Z transform. So as I explained in my previous video, when we come across such kind of terms, when we have two terms in multiplication in the denominator, we have to use the method of partial fraction. And instead of taking the entire term for the partial fraction, we just divide the numerator by Z. It means because we want to keep one Z safe to be multiplied it in the later stages. So what we get? We do the partial fraction for Z over Z minus 1, Z minus 3. Because if we divide Z square with Z, we left with Z only. So we have to work with Z as a numerator. So while writing the partial fraction for this, again both the factors are linear. So we get A over Z minus 1 plus B over Z minus 3. So the procedure is exactly same. So in the denominator we have Z minus 1, Z minus 3, which is product of these two terms. And to check whether it is correct or not, again you can see it from the question. It should be same what is in the original question. Then we need to look for terms to be multiplied with A and with B. So for that we multiply both A and B with the denominator, the LCM, which is Z minus 1, Z minus 3. So when I multiply A over Z minus 1 with Z minus 1, this term get cancelled and we left with Z minus 3. So we have here Z minus 3. Similarly, when I multiply this Z minus 1, Z minus 3 with B term, this term get cancelled and we left with only Z minus 1. Okay, so now to simplify it further, we can see that the denominators are same on both sides. So it is possible only when numerators are equal, which gives us Z is equal to A times Z minus 3 plus B times Z minus 1. Now there are two constants A and B to be whose values we need to determine. So for that we will make use of the values of Z. So again we substitute two different values of Z. So to make the calculation easy, we select the values from the denominator. So suppose if I say Z minus 1 is equal to 0, we get Z is equal to 1. What is the benefit of selecting the terms from denominator? That it cancels out one of the coefficients, either A or B. Like you can see, Z minus 1 is 0, it means the coefficient of B becomes 0. When we put Z minus 3 0, the coefficient of A becomes 0. And hence it simplifies our calculation. So now what we have to do? We have to replace Z here and these three places by 1. So when we do the calculation, we get 1 equal A times 1 minus 3 plus B times 1 minus 1. Now 1 and 1 cancels, it becomes 0. So we get 1 is equal to A times minus 2, which gives you value of A as minus 1 over 2. Okay, now we need the value of B, for which we need to substitute another value. So for that, let's take this one. So we substitute Z minus 3 equal to 0, which gives us Z is equal to 3. Substituting this again in this equation, now left side is Z, so it is 3 equal A times 3 minus 3 plus B times 3 minus 1. 3 minus 3 becomes 0, cancels out A term, so it is 3 is equal to 2 times B, because 3 minus 1 becomes 2. So this gives you value of B as 3 over 2. So now getting these two values of A and B, we substitute it here at the very first place. Remember that this term is just for the calculation purpose. Okay, just for the explanation. Original term is only this. Okay, so let's substitute it here and see what we will get. When we substitute it there, we get z over z minus 1 z minus 3 is equal to the value of a minus half z minus 1 plus the value of b 3 over 2 z minus 3. Now see, we got the value of a and b as constant. So this is the thing, whenever we use the partial fraction, we always end up with the constants value of a and b. So instead of z, if we would have taken z square, again we will end up with the constants value of a and b, and for that if we come across these equations, we are not able to find inverse z transform. So for that purpose only we kept one z safe. So that is why this thing is important. Now we multiply with this z here. Multiply both sides by z. Now this z is not like from anywhere, from our own thing, we are using this z. So what it will give you, here it becomes z multiply z, which become z square over z minus 1 z minus 3. This is equal minus half z over z minus 1, and then plus 3 over 2 z minus 3. So see, we didn't change the question. Again, this is not the part of the question. The original question was z square over z minus 1 z minus 3. Okay, so now apply inverse z transform on both sides. Apply z inverse to both sides. So what we will get? In finding the inverse z transform of z square over z minus 1 z minus 3 is same as finding the inverse z transform of these two terms. Now minus 1 over 2 is a constant, we can take it outside. So it is inverse z transform of z over z minus 1 plus again 3 over 2 is a number, take it outside, multiplied by inverse z transform of z over z minus 3. Now using the rule, this gives you 1, this gives 3 power k. So we will get the final answer as minus 1 over 2 times 1 plus 3 over 2, 3 to the power k, and we are done. So in the same way, this is the key idea. Like suppose if you have another example, like you have to find the Laplace transform of z square minus 5z, c divided by z plus 1 z minus say 7. Then in this case again it's clear that you have to use the method of partial fraction. So what you will be doing for that, you have to divide this term, right, by z. So it's always better write z square minus 5z as z multiplied by some term. So what it will be, z square, when you take z outside we left with z minus here with 5. So while doing the partial fraction for this, you will be doing partial fraction for z minus 5 over z plus 1 z minus 7, which gives you a over z plus 1 b over z minus 7. Then you complete the calculation, and after getting the values of a and b, multiply it with this z that you kept safe before finding the inverse z transform. So this can be completed in the same way. The factor with a will be z minus 7, with b will be z plus 1. Now we compare the numerators. Z minus 5 equal a times z minus 7 plus b times z plus 1. Now again we have two constants a and b. So we have to substitute two different values for z. So again we get those values from here. So we substitute z plus 1 equal to 0. That will give you z is equal to minus 1. Okay, this is one value. Second value we'll get from here by substituting z minus 7 equal to 0, which will give you z is equal to 7. So we are going to substitute these values here, z here, here and here. So when we will do this calculation, z is minus 1 minus 5 equal a times minus 1 minus 7 plus b times minus 1 plus 1. So minus 1 plus 1 becomes 0. This cancels the coefficient of b. This gives you minus 6 is equal to minus 8 times a. That is a is equal to minus 6 divide minus 8. We can divide both terms by 2. So it is 3 over 4. This is the value of a. Similarly, when we solve it for 7, what we will get? 7 minus 5 equal, again we are substituting here, a times 7 minus 7, b times 7 plus 1. 7 minus 7 cancels out, becomes 0. So here 7 minus 5 is 2. It is equal to 8 times a. So this gives a is equal to 2 over 8, which gives you 1 over 4. This is the value of, sorry, I did a mistake. It's not a, this is b. Because a cancels out now. So 8b, b. So this is the value of b. Now after getting values of a and b, substitute it here at the very first place where we introduced a and b. So what we will get? We will get z minus 5 over z plus 1 z minus 7 is equal to a, which is 3 over 4. 3 over 4 divide z plus 1 plus the value of b, which is 1 over 4. So 1 over 4 divide z minus 7. Okay, now but this is not your actual question. In your question you are not having z minus 5, you are having z square minus 5z, isn't it? So we have to now multiply with this z that we kept seeing. So multiply both sides by z. So see, we can able to do this step only if we have done this step. If we keep the z safe here, keep one z safe for end. Because if you are not doing this, we are not able to do this step. Okay, so what you will get? Originally you were having z minus 5 divide z plus 1 z minus 7. You multiplied it with z so that we return back to the original question. Again, this divide z is not part of the question. Okay, this is equal 3 over 4 as we multiplied with z, z divide z plus 1 plus 1 over 4. We multiplied with z, divide z minus 7. Now apply z inverse on both sides. Apply inverse z transform on both sides. So what we will get? Finding inverse z transform of this term, which is same as our question, z, say z minus 5 over z plus 1 z minus 7 is same as finding the inverse z transform of this terms, which is 3 over 4 inverse z transform of z over z plus 1 plus 1 over 4 inverse z transform of z over z minus 7. So this is nothing but 3 over 4. For this term we get minus 1 to the power k plus 1 over 4. The second term gives you 7 to the power k. Remember, we are making use of the rule. Z transform of a power k is z over z minus a. So when we are taking inverse, we are using it in this way. So if it is z over z minus a, we get plus a and its power k. So if it is z plus a, if it is z over z plus a, it will give you minus a to the power k. This is the rules. And you have seen in previous classes how to apply this rule. Okay. So hence we get our answer. Inverse z transform of z square minus 5z divided by z plus 1 z minus 7 is equal to this value. This completes the solution. I hope it's clear now.